This is the video for calculations using significant figures. Essentially, we're going to be taking the rules for significant figures that we talked about and actually doing some math with them. So before we can do any addition, subtraction, multiplication, division, anything like that, we can talk a little bit about rounding. The rules for rounding that we use in chemistry is the same as the rules of rounding that you've been using literally as long as you've been rounding. If it's from a 0 to a 4, it rounds down. If it's from a 5 to a 9, you raise the number. Rounds up, rounds down. Same rules. So we have a number 21.409653, and we're going to round it to the requested number of significant figures. So first it says round this to 2. Well, 1, 2, 21. And we're going to look at the third digit. It's a 4. So according to our rules, 4s round down. So if we were to round this number to 2 significant figures, just be 21. Or 21 with a decimal, either one would be technically considered right. Both of those have 2 sig figs. If I want to round that to 3 sig figs, well, 21.4. There's 3 sig figs. We look at the fourth, it's a 0. Sure enough, that stays as 21.4. Let's look at rounding this to 4 sig figs. 21.4. There's 3. Then we say, okay, well, the last number that we're going to have to put is that 0 there next to the 4. But let's look at the 5th digit. The 5th digit is a 9. And according to our rules, that means we round up, which means if I'm going to round this to 4 sig figs, it's going to be 21.41. Let me erase that and write it a little bit better. 21.41. That 9 rounds my last significant figure up to a 1. I want to round this number to 5 sig figs. 21.4. This one's going to be kind of interesting because you'd initially want to say 21.40 and say, okay, well, 9 is my last one. Look at your 6th digit. Well, your 6th digit is a 6. And according to our rules, that means it's going to round up. Well, if I take 9 and I round it up, that's going to take the 9 that would normally be there at the end and turn it into a 10, which means this number is going to be 21.410. There's my 5 decimals. Don't worry too much about that. We're not going to be giving you too many problems where you have to worry about that weird 9 rounding up turning into a 10. So if you're a little lost on that, don't worry about it. Let's say I want to round it to 6 significant figures. 21.4096 would be the 6th significant figure. So we look at the 5 to determine whether that 6 gets to stay a 6 or whether it has to round up. The 5 rounds up. So we have 21.4097. Last but not least, 7. 21.4096. 1, 2, 3, 4, 5. 6 significant figures. Last, we'd look at the 5. That's going to be our 7th significant figure. So let's look at the next one, the 8th. It's a 3. 3's round down. So we're going to leave the 5 alone. Here's another way that we can make you do it. Instead of giving you one number and making you round it to various different levels, we want you to take all of these numbers and round them to exactly 4 significant figures. Remember, this whole times 10 portion of it does not count. We don't look at it for significant figure purposes. That's just telling us what that number actually is. You have to include it, but it doesn't count for significant figure purposes. So you just look at the coefficient, 4.000574. Well, let's count significant figures. Here's 1, 2, 3, 4. That 4th 0 is all 3 of those zeros are sandwich zeros, so they're all going to count. So 4.00. Since this is our 4th number, our 4th significant figure, you got to look at the next number there, the 5, and you got to use your rule. Well, the 5 rounds up. which means that last 0 is going to turn into a 1, 4.001. But 4.001 isn't this number, because remember the number was originally 4.0000574 times 10 to the 5th. You cannot forget that this number is in scientific notation. So if I just write 4.001, that's not the number. You rounded the coefficient, that's great, but you've now changed the number. Which means if you're rounding numbers in scientific notation, you always have to remember to include the scientific notation piece that comes afterwards. That way you're keeping the number, the same number, just rounded. Let's look at the next one, 375.6523. Round it to 4 significant figures. The 3, the 7, the 5, those all count. The 0.6 will be your fourth. So you look at the next number, 5. 5 again rounds up, which means this is going to be 375.7. The 5 tells me that I need to round that 6 up to a 7. Last but not least, 89,762,334. 89,762,334. Same general process, right? The 8's going to count, the 9's going to count, the 7 and the 6, that's going to be 4. You'll look at your fifth number. There's a 2. Well, according to our rules, a 2 rounds down. So the 6 doesn't change. 8, 9, 7, 6. And here's where y'all tend to make a lot of mistakes. My number was originally 89,762,334. If I just leave my number like this, that number says 8,976. Those are not the same numbers. It's rounded to 4 significant figures. It definitely has 4 sig figs, but it's not the same number. So we have to add a number to ensure that since I started at 89 million, I end with approximately 89 million. Essentially, you have to add some numbers in order to get your place values to be the same as when they were when they started. Well, the only number that you can add that doesn't change the value of the number effectively is 0. So you're going to add zeros to essentially replace all of the numbers that you are ignoring, which means that 2, that 3, and that 4. So we're going to add 4 zeros to the end of this number so that my 89,762,334 is still 89,760,000. Alternatively, and some students really like this, you could translate that into scientific notation. You could turn your 89,762,334 into 8.9762,334 times 10 to the, what would that be? Times 10 to the 7. Times 10 to the 7. And then solve it that way. If you round this in scientific notation, you don't have to worry about all these extra zeros, but you do have to have the ability to do that problem in scientific notation. Depending on what your skills are, how confident you are in your ability to do this math, we would accept either one. So, knowing a little bit about rounding, anytime you're doing any kind of math function, so multiplication, division, addition, or subtraction, you're going to use a particular set of rules in order to determine how many significant figures you have in your final answer. We have to use these rules in order to essentially show how confident we are in our final answer, which corresponds to this idea of precision that we've talked about already. You can only be as precise as your least precise number. You can only be as confident as your least confident answer. It's kind of like that analogy to a race. You're only as fast as your slowest runner in a relay. You can only be as precise or confident as your least precise number. So, for multiplication or division, anytime you do any kind of multiplication or division math problem, you are going to round your final answer to the least number of sig figs in the calculation. Okay, so I know it's a little confusing, so let's do an example problem where you see it. So number 1 says 1.35 times 2.467. And when you do that in your calculator, it spits out a long string of numbers, 3.33045. But when you give your final answer, you can only be as confident as you have the precision and the significant figures to be confident in. Well, 1.35 has three significant figures, 1, the 3, and the 5. 2.467 has four significant figures, the 2, the 4, the 6, and the 7. When you're doing a multiplication or division problem, you have to use the least number of sig figs that you have. Well, one of my numbers has 3, one of my numbers has 4. Because you're in this class, we have to be confident enough that you know that 3, in fact, is less than 4, which means you're going to round your final answer to 3 significant figures. So 3.33045 turns into 3.33. That's your final answer. That's as confident as you can be based on your previous measurements, your previous numbers. Let's look at number 2. 1,035 times 42. Well, 1,035 has four significant figures. The 1, the 3, the 5, and the 0 is a sandwich 0 since it's between the 1 and the 3, so it counts. But 42 only has two significant figures. Similarly to number 1, we assume, because you're at this point in your academic career, that you know 2 is less than 4. So we're going to round our final answer to two significant figures. 43,470 turns into 43,000. Two significant figures, but notice I have to put some zeros in there in order to ensure that since I started at 43,000, I still end as 43,000. So don't forget you have to maybe add some zeros. They're trailing zeros with no decimal, so they're not significant, but they need to be there in order to ensure that you are ending with approximately the same number that you started with. Last but not least, 0.0021 divided by 3.2 times 0.01. Remember when you type this number into your calculator, you put the things in the bottom on a parenthesis so that those are multiplied together first before it does the division. In fact, if you have your calculator handy, I highly recommend you type that into your calculator real quick. Make sure that you know how to do these kinds of calculations because you're going to be having to do them on the exams. And when we look, we have 0.0021. Well, these three zeros are all leading zeros, and according to our rules, leading zeros never count, which means 0.0021 has two significant figures. 3.2 has two significant figures. 0.01 only has one significant figure. Both of those zeros are leading, and according to our rules, leading zeros never count. Which means even though we have the ability to calculate out that value to be 0.065625, that's way more precise than we're allowed to be based on the measurements that we took. So let's say you took those measurements that gave you 0.0021 and 3.2 and 0.01. The least confident answer you have is that 0.01, which means your answer has to match your least confident measurement, your least confident result. Which means when we round our answer, we know these zeros and 0.0, leading zeros, they don't count. 6 would be our only significant figure, so we got to look at the 5 to determine whether that 6 rounds up or gets to round down. Since it's a 5, the rules say round up, which means 0.07 would be the best, most confident answer we could give in this case. So when we're doing addition, multiplication and division, we use the least number of sig figs. We have a slightly different rule for addition and subtraction. Instead of having to count the number of sig figs for addition and subtraction, we actually just look at decimal points, which means for addition and subtraction, you do not have to count the number of sig figs in your problem. What that means is if you're still having trouble counting sig figs, that's okay. You should still be able to add and subtract and get to the correct value, essentially. So let's look at number 4, 12.01 plus 35.2 plus 6. The least number of digits past the decimal in that problem is 0, right? The 12.01 has two numbers past the decimal. 35.2 has one number past the decimal, but 6 has no numbers past a decimal. In fact, it has basically no decimal there, which means you have to round your answer to the least precise value you have, which means no numbers past the decimal. We have to round 53.21 down to 53. Notice there's no numbers past the decimal there. Let's look at number 5, 55.46 minus 28.9. 55.46 has 2 numbers past the decimal. 28.9 has 1 number past the decimal. So when I round my final answer, I have to round it to a single decimal place, which means my 26.56 turns into 26.6. 1 decimal place, 1 decimal place. Last but not least, number 6, 0.15 plus 1.15 plus 2.051. Well, 0.15 has 2 numbers past the decimal. 1.15 has 2 numbers past the decimal. 2.051 has 3 numbers past the decimal. So 2, 2, and 3. It's safe to assume that y'all know that 2 is less than 3, we hope, which means you have to round your final answer to 2 numbers past the decimal. 3.35 will be your final answer there. So 2 separate rules. Please make sure you know when you count the decimal places, when you count sig figs. You will have to do both of these separate rules, and you have to be able to keep track of them.